Hey, hello everyone. Welcome to the new session of Quick Hands On. So today is Game of Thrones special. So please stay till the end. We'll see how this is related to Game of Thrones. Yeah. So also we have planned to change the format of Quick Hands On series. So earlier what I was doing, I was posting videos on topics like decision trees. So I thought, okay, let's just go with an example, and I think that will make it more clear. Okay. So this is the job description of one data scientist profile. So this is first is the key responsibility. So I'll not like these are responsibilities which you will need to do. Like these are your responsibilities if you are once if you are selected in that particular organization. But okay, so what are the skill set that you need to get that job? This is where this is the point where we are looking. This is the point where that we are looking for. So if you go to this particular point, so it says working experience on current industry problems in NLP like question answering, sequence modeling, etc. So how it would be if we have a project on question answering, right? So this will solve many things. So first it will show that you know concepts of NLP because you are able to build a question answering, and you are working on certain things which are in trend, like which people look for before hiring someone. So and learning question answering is always a fun. Like any topic that you are going to learn is always a fun, right? You learn many concepts. So there are many advantage of doing that way. So this is just an experiment. I'll need your guys' feedback. How do you like this thing? Like, do you want to continue in this format, or do you want me to switch back to the previous version? Just please let me know. Okay. So first of all, like first bringing this question answering for building this question answering thing. What the first thing that we need is, yeah, exactly the data set. So the data set that we are going to use here is Squad 2.0. So this is Stanford question answering data set. This is an introduction data set. I'll just read it out. So it's a reading comprehension data set consisting of questions posed by crowd workers on a set of Wikipedia articles. The main point is coming now, where the answer to every question is a segment of text or span. So that answer should be present in the article, right? So this is the leaderboard. So they are also considering like, but also abstain when presented with a question that cannot be answered based on the provided paragraph. So this is like future, we can think over it. But currently we are just building a question answer. Like if you will just once question comes up, your model should be able to answer according to that particular question from the paragraph if it is present inside that paragraph. Okay, cool. So let's just start like creating the idea. How will you build this? So I think the first thing that would come to your mind is that you want to build something that will capture that similarity or synonyms. No, didn't that came in your mind? Okay. Why it came into my mind is that, let's say I'll take one example. So let's say we have an article on IPL, IPL 2019, and I'm a very big fan of Mahendra Singh Dhoni, so I'll take that example. So as you all know that Mahendra Singh Dhoni had played a great inning against RCB in the recent match where they unfortunately lost by 1 run. So in that game, that there's an article on that game, and the question that has been posted on that one is that tell me one game or in which game Dhoni played brilliantly, right? So this is the question. So if in your article instead of brilliantly some other synonym of that brilliantly there is like this is a match in which Dhoni played very well or very brilliantly, or like some synonyms of brilliantly. So if you don't know that very well is a synonym of brilliantly, then you don't then you won't be able to answer. You'll say, okay, I can't answer this according to the paragraph because brilliantly does not exist. So that's why I think that having a synonym thing is a need is a must here. So the how that we can solve, right? NLTK is always there to solve this type of issues. So there is wordnet is there. So what I'm doing is that I'm taking the word live here and taking the synonym of that. So synonym name like this, what the synonym that we are getting is populate. Okay, so if you lematize it, it will show you the populate thing. Okay, then what then we can also see the definition of that word. So the definition of that word is inhabit or live in, be an inhabitant of, like, makes sense. And we can also see the examples of like all the synonyms. So people lived in Africa millions of years ago, lived is there, then inhabited is there, the sentence of inhabited is there, then this is dwells is there, populating is there. So yeah, that basically solves our problem, right? But there is one more problem here. The problem is, okay, now we currently have this similarity thing, but uh, we can't, like, they are not represented in a vector format, right? Like we don't have a vector representation currently that we can deal with. So okay, so many of us will suggest, okay, go with one hot vector encoding. So one hot vector encoding is great. Like you will have a vector for each and every word. So vector, what basically a vector is? Vector is basically a set of numbers, right? So you will have like for ML models, one hot like vectors. You can't feed directly strings. You need to convert into vectors. So vectors are needed. So yeah, so one hot encoding or one hot vectors solve this issue, right? Okay. So I'll just take one example. So let's say you all must be familiar with the Trivago ad, right? So in that, let's say I search for hotels in Bangalore. So it showed me the hotels in Bangalore, but it did not show me the motels in Bangalore. So it should understand, okay, hotels and motels are similar. So if we'll see the one hot encoding of vector, so it's not always the case that hotel and motel will be similar. So they do not have any similarity measure. So what we basically need here, we need a vector for every word, and the other thing is there should be a similarity measure as well. So there are 2 points that we need. One is vector of every word, and the similarity measure of with other word, like which are synonyms of that. So these two things that we need. So here comes the Word2Vec. So the concept on which the Word2Vec is based is that you shall know a word by a company it keeps. Means what this basically means is that the meaning of a word is defined by the context of the word, like the words that are surrounded, the words that surround that particular word. Okay, I'll just go to the algorithm that we can use to create the vectors out of words. So the idea is that we have a very large corpus of text. Okay, so and every word in the fixed vocabulary is represented, like we have to represent every word in the fixed vocabulary by a vector. Okay, that makes sense. And then how will you do this? We'll go to each and every position of the text and make that as a center word. Okay, and then use the similarity. So okay, I'll take an example so it will make more sense. Yeah, so the previous example that I took of Dhoni, we'll go with the same example. So let's say there is a sentence that Mahendra Singh Dhoni played very well against RCB in IPL 2019. Okay, let's say we chose very well as a center word. Okay, so now Mahendra Singh Dhoni played is one part of context, and the other part of context is against RCB in IPL 2019. So we will have one center word and the context, like the outside words around that center word. So C is a center word and there is a context outside word. So what we will do? We will represent that center word very well in vector form. Vector is set of number. So there is vector space. According to that, we will represent that word in vector. Okay, the vector form is there, and we will keep on changing those values, like that vector representation of that word, so that it will predict with higher probability of the context around it. Okay, I'll explain in the sense of example only. So now very well should be represented, like the sentence in that word very well center word should be represented in a vector format in such a way that it predicts with very high probability of Mahendra Singh Dhoni played and against RCB in IPL 2019, and it should represent or with very low probability to other sentence, like to other context, like the words which are not in context of that particular very well word, right? So this is how we come up with this will repeat with every word, so we'll come up with vector representation of the word. Okay, so this is there. Then first we are importing so now we'll see how we can use that and what all we can do. So I think the use case of Game of Thrones is coming up next. Okay, so let's just keep our nerves calm, and we'll go to that. Okay, so first what we are doing is that we are importing the dependency. So we imported numpy as nb, so that like for mathematical operation in Python, and then for interactive tool, like for interactive visualization, we are using matplotlib. We can also use the style use, and then sklearn you all must be aware about, but that's a machine learning library. And then we are using PCA. So what PCA does basically is PCA basically do dimensionality reduction. So what basically a dimensionality reduction is, so when you have a very high dimensional feature space, you want to reduce it, so you can either visualize it or you can work with that. So for that, like for that dimensionality reduction, when you reduce the dimension of feature space, for that purpose PCA is used. Also we are using GenSim. So what basically GenSim is now? So GenSim is not any deep learning library, but what basically it is that GenSim is like just open. Okay, so GenSim is a text similarity modeling. Okay, so text like used for word and text similarity modeling. Okay, so this is GenSim. So we are using keyed vector and glow to Word2Vec. So okay, so now what we are using here is that we are not using we are using a pre-trained vectors. What vectors? So globe is there. So Stanford again so has created this globe vectors for word. So they have like many words are there, and they have trained them. Unsupervised algorithm is there, and then they created a vector out of it. So we are using that one. So though GenSim do not provide a direct way to use this globe as a word2vec, like as a vector representation of words, but we can convert that into word2vec format. So this is a like glow file. First we'll take it like this is a data path. So okay, there is one more thing that to be mentioned, that it comes in various dimensions. So it comes 50 dimension, 100 dimension, 300 dimension, 500 dimension. So as much as the dimension will increase, the computational like the computational function or computational cost will increase, but it will be more accurate. Okay, so let's see how this basically how this file basically looks. So I have opened this five dimensional text. So then this word da is represented by this these many vectors. Okay, so and similarly 2 is represented by these vectors. So this is there. So like as this, the thing that I have opened is 50 dimensional thing, and but currently we are working with 300 dimensional glow vectors. So we took the data path and then we converted it into word2vec format. Okay, so now basically this is the model that we are creating. So we are using keyed vector. So what basically keyed vector is? So keyed vector is a module that implements word vectors and similarity lookups. Okay, that implements that word vectors and similarity lookups. Also, the main point is the main difference is that keyed vectors do not, like if you compare keyed vector and full model. So keyed vectors do not support further training. Okay, and also it has like smaller RAM footprint and similar interface. So we are using keyed vector here. Okay, so in keyed vector we just loaded that file that we converted into word2vec format. Okay, now comes the use case of Game of Thrones. So if you use the model and to find out what is more similar to the Targaryen, so basically I get very confused with these different family names. So I also like I watched up to season 4 or 5 I think. Then I lost interest. I know you guys would be thinking how whatever person I am, like who do not had much interest in Game of Thrones. But yeah, I watched till season 4, but I didn't find much time to watch also, and also I lost a little bit interest because I thought I know what will happen next. So okay, that's a different story altogether. So what we are doing here is that we are using model and we're trying to find out what is more similar to Targaryen. Okay, so yeah, Daenerys, right? Okay, Khaleesi is there. So other do not make more sense, but yeah, Daenerys is much more related to Targaryen, and also the measure of how similar it is also given. Right? Okay, next is which is what words are more similar to Lannisters? Okay, Tywin Lannister is there, Cersei is there, Tyrion is there. Yeah, all this makes sense, right? Okay, the if you go to Obama, okay, so what basically this value signifies that how similar they are to that, like how similar context were there when these words had occurred. So when Lannisters occur in the same context, many times Tywin had occurred, Cersei had occurred. So this is the score of that thing. Obama, when we are using Obama, Barack is very obvious answer that okay, whenever Obama occurs in a sentence in that same context, many times Barack will also occur. Then Bush is there, Clinton, Hillary, okay, these are there. Okay, in the same way, if we'll see for Indian, the India, Pakistani, Lankan, Sri, these are there. Okay, I tried with my name, but uh, unfortunately, or what should I say? So I'm not that much popular. So then the word that came most similar to Sachin is Tendulkar, Dravid, Ganguly, Saurav. Makes sense, right? Then if you see Modi, then there's Narendra is there, Lalit, Gujarat, Nawaz, BJP. Okay, Nawaz, Nawaz, I know Nawaz here. Okay, Nawaz, Pakistan Prime Minister. Let's say, yeah, fine, and makes sense. Then if you search Shah Rukh, then Irfan, Kareena, Kajol, yeah, all these things make sense, right? Einstein, if you'll do, then relativity, physics, Bohr model, oh sorry, Bohr is there, theory, quantum, makes sense. Okay, then you're searching banana, then coconut, mango. So as you can see, right, that it will it is grouping that particular thing. Like if food, then it will show food. Like the food will be similar. So this is very very good way of representing the word in a vector format and also measuring the similarity, right? Okay, so now what next we can do? Okay, yeah. So this is very cool. So we are trying to build up the analogy. So like let's just say Tyrion is the way Tyrion is related to Lannister, is similarly Dany is related to what? Okay. So yeah, the answer is as Tyrion is related to Lannister, similarly Daenerys is related to Targaryen. Makes sense, right? Yeah. So as America is related to English, India similarly India is related to India. So as Sachin is related to Sehwag, similarly Dhoni is related to Yuvraj. I don't know how this come up. So it might be like Sachin and Sehwag used to bat, had many partnerships. Similarly, Dhoni and Yuvraj had many partnerships, many famous partnerships. Okay, so as Austria is related to beer, similarly France is related to champagne. Makes sense, right? So as Obama is related to Clinton, Modi is related to Narendra. Does not make sense much, but okay, yeah, fine. Can we? It's not very obvious, but yeah, it's fine. As tall is related to tallest, similarly long is related to longest. Good is related to fantastic, bad is related to terrible. So yeah, this is very awesome, right? You can get the you understand that very well. So also we can do that model doesn't match. Okay, so out of like it's like odd one out. So breakfast, cereal, dinner, lunch. Cereal is the odd one out. Makes sense. Okay, so the now we as we had imported PCA at the beginning, so now the time came to do the PCA like to so it's the vector space is it has many dimensions, but we are reducing the dimensions into 2D so that we can visualize it. Okay, so let's visualize it. Cool. Okay. So if you can see all the Lannisters like Cersei, Tyrion, Tywin, all are grouped together. Daenerys and Drogo, though they belong to different clans, but still they are together because they were husband wife. And Catelyn Stark is there. They are separated from Lannisters. They are separated from Daenerys and Drogo. And then Theon is there. They are separated from all of them. Makes sense, right? In the same way, Narendra Modi, Ranveer Shah Rukh, Dhoni Yuvraj Sachin Dravid, maths, institute, university, college, school, homework assignment, history, English, class, test, makes sense. Same things are grouped together. In the same way, like foods will be grouped together, animals would be grouped together, countries would be grouped together. So, makes sense. This is too complex for life. So this is what Word2Vec is basically. So what we had learned is that we learned what by what concept we can train Word2 vectors, and once we have a trained vector, what all we can do with that. So what would be the next step in building the question answering? So okay, now we have a vector representation of each and every word that is present in that sentence, and also we can that the vector representation is also a good measure of similarity. What next? Okay, so the next I think would be bidirectional encoder or something like that, so that in a question or in as well in as in context, one like every word would know, okay, uh, what word follows it and what words come before that. And then after then there is attention layer will help us uh, finding out, okay, when this question comes, to what area of paragraph we need to put our attention to find out the answer of that particular question. Yeah, so we'll discuss those things in future in the next videos. I think you would have understood what we had discussed. If you have any queries, please do let me know. If any point is not very clear, please do let me know. I'll try to help you out with that. and this notebook would be uploaded on GitHub. So you can just go on and just try this out. It's very cool. I guess you will like this, and you can further read. So there is one Stanford course is also there. You can just go and do that. So yeah, this is very awesome, and we'll keep on building the question answer thing. Thank you so much for watching this video. I hope you liked it. Bye.